All right, hi guys. I'm going to do a quick lesson today on infiltration. We're going to talk more about this next week. But I just wanted to show you a quick animation, then we're going to talk about infiltration, and then we're going to go outside. So this is just showing you guys drainage in a basin. So in other words, if it rains in this area, we talked about drainage basins, all of this water is going to run downhill into this main channel and out the end there. Okay. Now, the idea of this water running off over the land is an important one because there's another process going on in this diagram that we can't see. This is the surface. We can see the water running over the surface really easily, but there's also water that's what we call infiltrating into the ground. Now, if you remember from your notes on the water cycle, there were a few terms down here at the bottom right hand corner that have to do with what I'm talking about. So, number one, infiltration down here, and number two, runoff. And these two processes are always like at war with each other. They're always opposites of each other. So, if you have a lot of runoff, that means the water is running over the land and into the lakes and into the oceans. But if you have a lot of infiltration, that means the water is not going necessarily into the lakes, but into the ground. Okay. And so you have a lot more infiltration when you have certain factors that are true, and you have a lot more runoff when other factors are true. And these factors we're going to actually talk about for the next few days. And we're going to do a lab actually next week related to this. So if you take a look at my notes, and by the way, these notes are online, they're called Infiltration, and I'll reference them from time to time. If you look at my notes here, water will infiltrate, in other words, will go into the ground when it's pulled by gravity. Okay. But in order for it to go into the ground, it has to be able to get into the ground and fill up these little spots in the soil and in the rock, and there has to be gaps for the water to get through. And so there are various factors that are going to affect whether it infiltrates or whether it runs off. And as you can see here, it says infiltration and runoff are always opposites of each other. Okay. Now, here are the factors, and we're going to look at some of these factors actually outside. We're going to go to my backyard. We're going to go to a stream nearby. I'm going to take my family on a trip to Baltimore Woods, and we'll take a look at a stream there. So this time of year is a perfect time to look at this because we have a lot of saturated ground because of, well, a lot of snow melt, a lot of rain, especially today after the snow this week. My backyard is a muddy mess, and I'm going to show you guys that outside. So the degree of saturation is important, whether there's vegetation present, what you're using that land for. This word porosity, which we're going to talk about, the shape of the grains, in other words, the shape of the soil grains, how it's sorted, which kind of relates back to our glacier stuff. Um, Permeability, which we're going to take a look at as well in a lab, how packed together it is, which we can look at maybe outside too. And then capillarity, another thing that we're going to refer to in a lab next week. So let's just start simple. We'll start with the basics. I want to just take a look at slope of the land and degree of saturation, and then we'll end there and talk about some other stuff later. Okay, so this I hope makes sense, and I'll show you guys this outside. So it says the steeper the slope, less infiltration will happen and more runoff will happen. And if you think about that, water wants to get downhill as fast as possible. So if it's on a slope, it's going to run down the slope and it's not going to have time to infiltrate into the soil. And so you would have a lot less infiltration on a slope and a lot more runoff on a slope. Okay, a steep slope. And you guys know that if you want to know where it's steep and where it's not steep, you look at a topographic map, the lines are closer together where it's steep. Okay, so if you want to know where infiltration is happening in my diagram, infiltration is going to happen where it's flat. And so these areas where the lines are farther apart, and you're going to have a lot more runoff where it's steep, like right here into this little stream here. Okay, so the slope of the land, and we'll look at that in my backyard actually. Slope of the land definitely factors into whether water will infiltrate or whether it will run off. Now, Degree of saturation is also important. If the ground is already filled up with water, then you can't get any more water into the ground. And that's when we have our worst flooding. So in my backyard, there's a bit of a puddle out there that my kids were playing with yesterday. I'll show you pictures. Um, that's because the ground was completely saturated. No more water could fill in the soil gaps, and therefore water just sat or sits on top of the surface. Okay, so if the water is filling up the ground, that's what we call saturated. Kind of like a sponge. If you put a sponge in water and then take it out and then you try to put more water into that sponge, it's not going to get any more water in. Trying to soak something up with a wet paper towel or a wet sponge just doesn't work. So if you have a saturated ground, no water can go into the ground, and so it just sits on the surface, and you have a lot more what we call runoff. Okay, so you have puddles, you have flooding, you have runoff. Okay, so saturation matters as well. All right, so I'm going to stop there because I want to talk about some of these other factors next week, and some of these things are going to relate to a lab that we're going to get into, and hopefully this short lesson will make sense. So I'll stop there, and we're going to go outside after this. Okay. Just one more thing before we go out in the field. I'm going to show you this actually in two different ways, but if you take a look at the diagram here, you'll notice that there's what we call unsaturated soil, saturated soil, and flooded soil. So notice the water level of each one of them. When the ground is unsaturated, we call it dry, right? The rain is falling on it, but it still stays dry afterwards. The water infiltrates through all the pores within the soil and falls down to what's called the groundwater, which we're going to talk about next week, but the surface is still dry. Now, if the ground is saturated, the water is coming right up to the surface. You can't get any more water in, and if it continues to rain, then all that water is just going to sit on top of the surface, and that's flooded soil. So just showing you the differences between all three of these and what you're going to see outside between unsaturated and saturated soil and flooded soil.